Okay, friends, what we're going to look at here is doing some problem solving using trigonometry. So we're going to start applying a lot of the rules that we've already learned in this unit. So don't forget stuff we know from grade 10, good old SOHCAHTOA and Pythagorean, and maybe sine law and cosine law. Okay, so that's where it gets a little bit tricky. You have to be able to figure out which method you're going to use. So here we go. So right off the bat, as soon as I look at this diagram, I'm going to say to myself, oh, I see a right triangle. Maybe SOHCAHTOA is going to come back into play, or Pythagorean, but we'll see as we read the question. So two security cameras must be adjusted to monitor a new display case. The cameras are mounted at point A and point B. Okay, and the display case is point D. Both cameras must aim at the center of the top of the display case. Okay, got it. Determine the angle of depression to the nearest degree for each camera. Okay, so remember, the angle of depression is measured from the horizontal downwards. So that means we're going to be finding this angle here and this angle here, just like that. So then if I want to know that, okay, well, now we got to start thinking about, okay, what are we going to do from now? What can we find given the given information? So I see we've got 13 meters flying around, we got 5 meters flying around. Okay, I want you to stop, hit pause for a minute, and think about how you can use the given measurements to help us solve this question. Okay, so hit pause, see you in a minute. Okay, did you think about what you could do with these different measurements in here? So what I noticed right off the bat is that they gave us the measurement of the depth here of D, and they gave us this whole length from the cameras to the back of the wall, which is 5 meters. So what that tells me is that this right in here, this is 5 minus 1.4. That's 3.6. All right, so now I know that length inside my triangle, and that's probably going to be really, really helpful to me. Okay, so now, oh, look at, I can find theta now. So to find theta, and I always like to write down what I'm trying to do for my teacher, it makes their life easier. I'm going to say from angle theta, this is opposite, this is hypotenuse. So I'm going to go sine theta is equal to opposite over hypotenuse. Sine theta is 3.6 over 5.2. And I'm going to sine inverse both sides. And again, that word inverse means I'm undoing something. That's what an inverse does. So I sine inverse both sides. You don't have to show me that step. I like to write it because I'm a huge nerd and I think it's proper to show, but if you don't show it, I'm not going to lose any sleep over it. Okay, and now friends, all we do is we go and pick up our calculator and we sub that in, making sure we're in degree mode. And guess what we'll get? We should get, when I put that in rounded to the nearest degree, I get 44 degrees. Okay, that's perfect. Okay, so now we've got theta's 44. All right, but we've still got to go and find alpha. Oh, geez, I don't know. How are we going to possibly find alpha from here? So that's where these application questions get a little bit tricky. You say to yourself, okay, well, what are we going to do from here? Well, we can look at this now. I see a couple different things we could do. What we could do is we could find this length right here. I'll call it X, maybe. And then we would be able to know how long this side is here. So that's one way to do it. Okay. The other thing that I also notice is another way you could attack this question is now, friends, we know that this angle here is 44. And looking at the big triangle right there, I think we can maybe use good old sine law on that. What do you think? Can we use sine law on that thing right off the bat here? Okay, so we want to use that there. Okay, that's what we're looking for. No, I can't use sine law right off the bat. I was kind of hoping I'd be able to use sine law. What else can we use there? Well, if we can't use sine law, what we could do is we could use, we could use cosine law, and that would give us that other side. And then once we know that other side, then we could go and find that angle. Okay, let's try it that way. I don't know if it's the best way to do it, but let's go for it. Okay, so we're going to use cosine law, and we're going to find this side over here. So let's go and do that. So cosine law. Remember, we're going to find what I know here is I know side, angle, side. So that's going to help me find a squared. So I'm just going to do it right here. So a is equal to what? Well, a squared is equal to my other sides. So b squared plus d squared minus 2bd cos a. And then we start subbing in our values. So a squared is equal to 5.2 squared plus 13 squared minus 2 times 5.2 times 13 times the cos of 44. All right. And so now what we're going to do is we're going to go and stick all that into our calculator. So when we sub that into our calculator, we go 5.2 squared. Remember, put the whole string right in your calculator. Minus 2 times 5.2 times 13 times cos 44. And approximately I get this. But when I go to put that in my calculator, I'm just going to go the square root of the previous answer so that I don't lose any decimals until the end, right? Until I decide to round. And so I get a value rounded to the nearest tenth of 9.9 meters. All right, well, how does that help us? So I go back up here and I say, okay, now I've got 9.9. Okay, now what can I do? Well, now, friends, now I can do the sine law that I was hoping for in the first place. So that's the thing with application questions, is you go to do them and you want to try your first instinct. And sometimes your first instinct works and sometimes it doesn't. That's the way it goes. You adjust your plan and go and find what you're looking for. Okay, so let's find that alpha now. So alpha, well, what's alpha? I'm going to use sine law here. So I'm going to say sine alpha over, maybe I'll call it sine. Yeah, that's fine. Sine alpha over 5.2 is equal to sine 44 over 9.9. Okay, to isolate for sine alpha, I multiply both sides by 5.2, just like that. And what I do from here is I sine inverse both sides. Now, for the sake of space, I'm just going to do it on this side, but just recall that we really are taking the sine inverse of both sides there, right? That's really what we're doing. Okay, and so I'm going to go sine inverse, and I'm just going to put that all into my calculator in one big step. Use that fraction button if you have it, friends. And I'm going to get myself an angle of about 21.4. So I'm just going to call it 21. There it is, friends. Okay, so again, not the only way I could have done that question, but certainly it worked. Okay, so again, when you're doing an application question, sometimes you're going to hit it right off the bat and you're not going to have any problems. And some other times you're going to start the question and go, oh, geez, what am I doing here to solve for these things? Okay, let's try one more. Okay, determine the height of AC to the nearest tenth. All right, so what am I trying to find over here? Well, I want to find AC. That's this right here, right? That's the great unknown. And I'm going to say to myself, well, how am I going to get there? I don't have enough information in triangle ACB to solve it. But if I knew side length CB, then I would be in some pretty good shape, right? So I think what we're going to do there is find that shared or common side CB first. And once we know side CB, we can find side AC. So here we go. Let's find side CB. So what's CB equal to? Okay, so in this bottom triangle, BCD, if I want to find that side, what I'm going to do is I got to find it. And I'm thinking sine law, cosine law, but right now I can't use anything, just kind of how everything's set up for me. But I'm going to find this other missing angle in here. And that other missing angle right there is 80 degrees. And now that I have that, that's going to be really helpful. So let's go sine law on this thing. So sine law, just going to erase that line there. I want to find side CB. So I know a pair. So that and that. Okay, so I'm going to say we want to find side CB over the sine of 48 degrees is equal to 35 over the sine of 80. And now multiply both sides by sine 48. And I'm able to just stick that straight into my calculator. And when I sub that into my calculator, I get to the nearest 10th, 26.4. Now, that's what I'm going to write down on my page. Again, I'm moving forward and I'm going to use this calculation to find another side. So in my calculator, what I'm using though is the full decimal. And so I'm using that answer button in my calculator. All right, so I have to truncate it on my page, but when you're doing your work in your calculator, you don't. Okay, so now we know this is 26.4. So now how can we possibly find side AC? Well, side AC, well, from 71 degrees, this side's adjacent and this side's opposite. That, my friends, sounds like tangent. So I go back and use some right triangle goodness. So I say tan of 71 is equal to AC over 26.4. But again, I'm using the full value when I put it in my calculator. 26.4 tangent 71. And when I stick that in my calculator, I get rounded to the nearest 10th, 76.7 meters. So there it is. So there's an example where we used, again, grade 11 math, sine law, and some stuff from grade 10. Okay, friends, I hope that helped. You're definitely going to get stuck a few times doing your practice. You just kind of have to sometimes struggle through it, try to find anything you can, and eventually you'll probably see, oh yeah, okay, I got that, now I can do this. Okay, it happens. I hope that helped. See you another time.